Hi everyone. Today we're going to go over lesson 15-2 and begin with visual learning.
How can you identify relationships between patterns? Think about this question during the lesson. Jack is training for a race. Each week he runs 30 miles and bikes 120 miles. He created a table to record his progress. How many total miles will he run and bike after 5 weeks? Can you identify any relationship between the miles run and the miles biked? You can use the rules add 30 and add 120 to help you complete the table. Since Jack runs 30 miles each week, add 30 to find the next term for the total miles run. How many total miles did Jack run after 2 weeks? How many total miles did Jack run after 3 weeks? Explain how you know.
All right, so this is very similar to what we did in the previous lesson. Using a table to chart our answers makes it a little bit easier to see what we're doing. So Jack, he is an avid runner, way more than me. I'm not so much of a runner myself, but go Jack, because he runs 30 miles each week. And so what we need to do is start right here with the 30, and then we need to add 30 to find the next term for the total miles run. So this is pretty simple. So week 1, he did 30 miles. And then we add another 30 here. And then we'll find out the total for the second week, which would be, that's like huge now, 60 miles for the second week. Okay, so then 60 would go right over here. Okay, and then we would just keep on adding 30 each time to figure out the next week's. Let's go ahead and see the video's explanation of this.
Jack ran 60 miles after 2 weeks because 30 plus 30 equals 60. He ran 90 miles after 3 weeks because 60 plus 30 equals 90. What is another way that you can find how many miles Jack ran after 5 weeks, besides adding 90 plus 30 plus 30? To find how many miles Jack ran after 5 weeks, you can also multiply 5 times 30.
Okay, so basically this is saying that repeated addition is the same as multiplication. So you can keep doing the same thing we've been doing, is just add 30, add 30, add 30, add 30, or just to make it a little bit easier and not have as many steps, we can do the same thing, which is 5 times 30, because we added 30 5 times.
Jack runs 30 miles each week. Drag the slider to see how you can multiply to find the total number of miles he runs.
Okie dokie, so we just do the slider here. And you can see over on the right, it's showing you the multiplication problem. So for the first week, it's just 1 times 30, because for 1 week, he ran 30 miles. The second one, there were 2 weeks, and he ran 30 miles in each week. So the problem would be 2 times 30, and the product would be 60. Third week, the same thing. 3 times 30 equals 90, and so on, until we get to the 5th week.
Add 120 to find each term in the pattern for the total number of miles biked. Compare the corresponding terms in the patterns. So the total number of miles biked is always 4 times the total number of miles run. Would subtracting the total miles run from the total miles biked help? Why or why not?
Okay, so let's go ahead and see what they say.
No, the difference is not the same for each week. Jack biked 90 more miles after week 1, 180 more miles after week 2, and so on.
Now you know how you can identify relationships between patterns.
Okay, so what it's basically saying is that the difference between the miles biked and the miles run is not the same each time, because this is going up exponentially times 4 times 4 times 4. So it's not going to be the same difference. If I take 120 minus 30, it's 90. But if I go here, 240 minus 60, is that still 90? No, it's not, okay? So that would be 180. So it's not going to be the same difference each time, is what it's saying if you're comparing them. Let's go ahead and we're going to go over and do some of the interactive practice buddies. Here we go. And let's go ahead and start this. And there's only 4 questions this time, and that's wonderful. Not quite as much to do. And remember, if you need to look at the table here as well, you can always click on the icon. Let's go ahead and read the problem. Number 1. Each team in a youth league has 16 offensive players and 8 defensive players. Complete the table to show how many offensive players and defensive players are on 6 teams. Okay, so, and it even shows you up here, use the rules, add 16. So you're going to add 16 here for that column, and add 8 for the defense to answer questions 1 and 2. So basically, all you need to do is be adding 16 plus 16 plus 16 plus 16 and so on to find our answers. Let's do a couple together. Okay, so I set up my problem here. 6 plus 6 is 12. That's correct. Regroup. I got 3 ones, so that is still 3. So my sum is 32, and 32 would go right here for 2 teams, would have 32 offensive players. Now to find how many would be on 3 teams, what do I have to do? That's right, I just need to add 16 again. So 2 plus 6 is 8, 3 plus 1 is 4. So then I just put 48 here. Okay, and then I just keep on adding 16 to get how many would be on 6 teams. And now for my defense, I'm going to do exactly the same thing, except with the number 8. So hopefully you know this. This is a doubles fact. 8 plus 8 is 16. So I'm going to put here 16. And then I just need to add another 8 for my 3rd week. Notice this is the same as multiplying by 8s, isn't it? 6 plus 8 is 14. I have to regroup. 24. Well, my goodness, look at this. We have a pattern going. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. So if you know your 8's facts, this should be pretty simple, okay? So this is how you would complete problem number 1. Let's go on to our second problem. All right, this says use the table to complete 3 through 5. Carly makes a table to show the relationship between meters, centimeters, and millimeters. Use the rule add 100 to complete the column for the number of centimeters. Then use the rule add 1000 to complete the column for the number of millimeters. How many centimeters are in 10 meters? How many millimeters are in 10 meters? Okay, so we just need to basically complete this table. I'm going to go ahead and get you started again. So remember right here, we have to add 100 for the centimeters and add 1000 for the millimeters. Okay, I always like to text code just to make sure I'm doing the right step. Let's start with centimeters. Okay, these are my hundreds. Now I could write it out, 100, and then I have to add 100. Okay. But I think that you guys can probably count by hundreds without writing out the whole addition problem. So basically, I'm just doing 100, I add 100, 200. What would be my next one? If I add 100 to 200, what would be my sum? That's right, it would be right here, 300. Okay, so you see the pattern? 300, okay, 400, and so on. Okay, and the same thing is true basically for the millimeters. When I'm adding 1000, the only difference is I have an extra 0. So if I add 1000 to my millimeters, right here, it would be 2,000. I need to add another 1,000, so it would be 3,000. And so on. Okay, so that's how you would do question number 2. Let's move on to question number 3. A recipe for a cake uses 6 1/4 cups of white flour and 4 1/5 cup of wheat flour. How many more cups of white flour than wheat flour are used in the recipe? Write an equation and complete the bar diagram to solve. All right, so we have to figure out what our question is asking us. So basically, we've got this number here, 6 1/4 cups of the white flour and 4 1/5 cups of the wheat flour. And the question is, how many more cups of white flour do we have than wheat? So we're comparing, all right? You can do this a couple of different ways. When I'm comparing, I like to subtract. You could do that, or you can, again, look at these different bar diagrams below. So let's look at our answer choices. Okay, so right here we have where it's showing the difference with the bar diagrams. So if you look at problem A, or answer choice A, we have 4 1/5, 6 1/4. So these are the numbers we're working with here. And it's saying that the difference, this answer choice is saying the difference between the two would be 2 3/20. Okay. But this one is, if you look at it, it's saying that 4 1/5 is actually, do you see how this is showing it bigger than this? Than 6 1/4? Well, let's look at B. This one is showing that 6 1/4 is bigger than 4 1/5, and that the difference would be 1 1/4. Let's look at the next answer choice. For C, 4 1/5, 6 1/4, and then 2 1/4. Okay, I don't like this one either, because do you see how 4 1/5, this bar is bigger than the one for 6 1/4, that doesn't make sense because the number 6 is bigger than 4. So I know that the bar for this number here should be the bigger one. Okay, so I can eliminate C right now. And I can also eliminate A right here because again, you see how the 4 is bigger than the one with the 6? No way, okay? So basically, I'm between B and C, D for my answer choices, excuse me. So now I have to figure out if the difference is 2 1/20 or if my difference is 1 1/4. Okay, well, how am I going to figure that out? Let's go ahead and we have to find a common denominator. And I would also suggest switching it to a fraction greater than 1. So let's do that. Okay, so you can see here that I changed these into fractions greater than 1. How did I do that? Well, remember that I did 6 times 4, which would be 24, and then I added the 1 to get 25. My denominator stayed the same as fourths. I did the same over here. 4 times 5 is 20. I added the 1 to get 21. So now I have 21/5 and I have 25/4. Okay, but I still have a problem. What's my problem? That's right, I need to have a common denominator. So I'm thinking that a common denominator could be, I'm going to say 20 because I know if I multiply 4 times 5, it equals 20. So I'm going to need to multiply this times 5, and I'm going to need to multiply this by 5 because I want to make it into 20ths. Okay, so I know that 25 times 5, I could do that over here, but I'm actually just going to think about quarters, okay? So I know 5 quarters would be $1.25, so I'm going to have 125 here for the top, okay? And then again, my denominator, 4 times 5 is 20. Okay, so now in order to get 20ths over here, I'm going to need to multiply the denominator by 4, and I'm going to need to multiply the numerator by 4, okay? So if I do that, I'm going to get 84, and I'm going to get 20ths on the bottom. Okay, so now I have a common denominator. This is still going to be 20ths, okay? So I know right away I'm not going to change my denominator. I'm going to keep it the same as 20ths. All right, and then I just need to do my subtraction problem. Oops, that is a 2, I promise. 125 minus 84. Right there. Okay, so I've got 5 minus 4, 1. 2 minus 8. Oh, I can't do it, so I need to regroup. 1 would be a 0, and then this would be a 12. So 12 minus 4 is 4. Okay, so now I've got my difference here, 41/20. Okay, but now I need to change it back to a mixed number. Okay, how do I do that? Well, I need to divide. And I've got 41, and I'm going to divide it by 20. Okay, so how many times would 20 go into 41? Well, I know 2 times 2 is 4, so 2 times 20 would be 40. So I'm going to do 2 times. Whoops, and then I'm I know that 20 times 2 is 40. So I need to subtract to find if I have a remainder, which I do. 1. Okay. So what is going to be my correct answer choice looking at this right here? I'm going to let you try to figure that out. So when I make that, what we just did, that division into a mixed number, is it going to be 2 and 1/20, or is it going to be 1 and 1/4? That's what you need to decide. That's all for now. Next time we'll go ahead and go over question number 4 together. See you then.